Hello student, in the lecture of hello alkane, hello arenes, today we will discuss elimination reaction. Dear student, today we will discuss elimination reaction with metals. Okay, now discuss elimination reaction. Dear student, elimination reaction is occurs when beta hydrogens present. Elimination reactions occurs when beta hydrogen present. Dear student, how to identify in a given compound beta hydrogen are present? Dear student, the carbons which is attached by hydrogen or leaving group or functional group is known as alpha carbon, and the adjacent carbon of alpha carbon is known as beta carbon. So here alpha carbon because it is attached with the leaving group, functional group, hydrogen, so it is alpha, and the neighbor carbon is here, so it is known as beta carbon. The hydrogen present on the beta carbon is known as beta hydrogen. Dear students, in this reaction, in this compound, in this halide, you observe here at the beta carbon one hydrogens are present. This is known as beta hydrogen. When in a reaction in a given compound beta hydrogen present, then elimination reactions occurs. Okay, here in this compound, in this halides, beta hydrogen present, so we say that in this reaction beta hydrogen elimination reactions occur. Okay, dear student, in this reaction the first is leaving group leave from their site. Here leaving group leave. When leaving group leave, the deficiency of electron generate on this carbon, that is alpha carbon, to complete their deficiency. Hydrogen donate their electron to the carbons. Okay, so due to donating of electron by the hydrogen acquire positive charge. Means hydrogens have deficiency of electron, therefore the base or nucleophile lose their electron pair to the hydrogen and generate BH, and the leaving group which is leave from here is as a anion. Dear student, when hydrogens leave by lose their electrons pair, these electron pairs here occurs as a multiple bond. So here alkene are formed. The compound is alkene is formed. Okay, student. Yes, student. Now discuss elimination reaction by the example. We have an example: second bromopentane. Why second bromopentane? Dear student, here bromine at the 1, 2, first, second, third, fourth, fifth. Here second position bromo are present. So we say that for bromo second bromo, and fifth carbon went for single bond N. This compound is second bromopentane. Dear student, in presence of alcoholic KOH. Dear student, here you observe hydrogen attached with this carbon. This is the alpha carbon, and the carbon present adjacent of the alpha carbon is known as beta carbon. Here two adjacent carbon, so we say that both are the beta carbons. Here two beta carbons, and the beta carbons here also hydrogen, here also hydrogen. It means we have a beta hydrogen at the both side of alpha carbon. Okay, so elimination take place at the both side, at the this beta and this beta. Dear student, when elimination occurs on this beta, elimination occurs when first beta, like here. Dear student, then firstly bromine leave from here, and the hydrogens of this beta, the hydrogen present here, 3 hydrogen, out of 3 hydrogen, 1 hydrogens leave their electron pair, bond pair here, and generate HBr, both react each other and generate HBr, and here a new bond formed, that is double bond, like here. Dear student, the new obtained compound is known as pent, 5 carbon pent at the first position in, this is the pent 1 in. But if the reaction take place by this beta hydrogen, like here. Dear student, when the bromines leave from this side, their side, hydrogen lose their electron pair, like here, okay, and generate HBr, and a new bond formed between alpha and beta carbon, okay. The compound formed is like here. Dear student, in this compound, number of carbon 1, 2, 3, 4, 5 carbon. So right here pent 1, 2 at the second position double bond. So right here pent 2 in. Okay. It means, dear student, in presence of base, in presence of nucleophile, a alkyl halide which is contain beta halogen, more than 1 beta halogen, they formed more than one type of alkene. Like here, this alkyl halide formed pent 1 in and pent 2 in. Okay. Dear student, in this case, how do we judge which is the major product and which is the minor? The obtained product, only one product are major and other is minor. For the identifications, who is the major product? Use Set-Zep rule. So now here, if more than one beta hydrogen atom, like here more than one beta hydrogen, if more than one beta hydrogen atom, then according to Set-Zep rule, alkene which has the greater number of alkyl group attached to the doubly bonded carbon atom is formed as major product. Dear student, when more than one beta hydrogen, then for the identification of who is the major product, you apply Set-Zep rule. Which rule? Set-Zep rule. Set-Zep rule say that the alkene means here pentene, 2 in, pent 1 in. Alkene which has the greater number of alkyl group attached to doubly bonded carbon atoms are the major product. Dear student, you observe here this carbon are the doubly bonded carbon in the pent 2 in, and in pent 1 in this carbon is doubly bonded carbon. Okay, these carbons are doubly bonded carbon, and Set-Zep say that who is the major product? Major product is contain doubly bonded, when doubly bonded carbons contain greater number of alkyl group. Dear student, you observe here a doubly bonded carbon contain here one alkyl group and one alkyl group here. Here, doubly bonded carbon contain two alkyl group in this compound. One alkyl group here and one alkyl group here. Here, two alkyl group present are two alkyl group directly attached to doubly bonded carbon. But in this compound, dear student, you observe here alkyl group here, but here no any alkyl group at this site. So in this compound, only one alkyl group are present. Only one alkyl group are present. But in this compound, two alkyl group directly attached to the doubly bonded carbon. But in this compound, only one alkyl group directly attached to the doubly bonded carbon. According to Stetson rule, alkene which has a greater number of alkyl group attached to the doubly bonded carbon atom is formed as major product. In this compound, number of alkyl group directly attached with the doubly bonded carbon is greater than pen 1A. So we say that this is the major product and it is minor product. Like here, dear student, this compound formed in this reaction 81% and this is 19%. It means this is the major product and this is minor. Why it is major? Because it have maximum number of alkyl group directly attached with doubly bonded carbon atoms. Okay. Here student, now discuss reaction with metals. Reaction with metals. Dear student, firstly discuss some common things, that is organometallic compound. Are you know that what is the organometallic compound? Dear student, active metals like sodium, magnesium, lithium, etc. combined with alkyl halide give compound containing carbon metal bond is known as organometallic compound. Dear student, for example, reaction with magnesium. Dear student, when alkyl halide react with magnesium, it forms Grignard reagent. Dear student, the Grignard reagent discovered by Victor Grignard. Okay. Dear student, like here, a alkyl group, alkyl halide. When the alkyl halide react with active metal like magnesium in presence of dry ether. Dear student, we use here dry ether. It is because we use dry ether because the magnesium is more active than with H2O. Dear student, because the sodium, magnesium, lithium are the very active metals with the water. So don't use water in these reactions. Use dry ether. Okay. Dear student, when alkyl halide react with active metals in presence of dry ether, dear student, it formed RMgX. RMgX means here carbons of alkyl group joined with the metal by the covalent bond. Dear student, but the nature of this covalent bond is polar. Okay. This is known as RMgX. RMgX is known as Grignard reagent. Okay. When someone asks what is the Grignard reagent, dear student, you say Grignard reagent is RMgX. How it is formed? It formed when alkyl halide react with active metals like magnesium in presence of dry ether. Okay. Dear student, for example, we have the ethyl bromide here, that is alkyl halide. When it react with the active metal like magnesium in presence of dry ether, it produces A covalent bond, the carbons of ethyl bromide form covalent bond with the magnesium, like here. This is known as ethyl magnesium bromide. Okay, ethyl magnesium bromide. Dear student, in Grignard reagent, you know that metal acquire positive charge. So alkyl group acquire negative, partially negative charge. Here magnesium have partial positive and alkyl group have partial negative charge. Okay student. Dear student, due to formation of partial charges, we say that the covalent bond found between the alkyl and magnesium is covalent but polar in nature. Okay. So we say that this bond is polar covalent bond. Dear student, it is highly reactive and react with the any source of proton. Source of proton means, dear student, the compound who give the protons is the source of proton. Dear student, like water give H plus and OH minus. It means water is the source of proton. Alcohol also give the H plus ion, so it is a source of proton. Amines also give the H plus ion, so we say that amines are the source of proton. Dear student, when Grignard reagent react with the compound which is the source of proton, it react very fast and produce alkane. Dear student, in this reaction, you observe here RMgX react with water that have the proton. Water is HOH. Dear student, during the reaction, RH is formed and this is formed MgOHX. Here R and H from the water combined and formed alkane, that is RH, and MgOHX is also formed. Okay. Dear student, now discuss the second reaction, that is the organometallic compound. Okay. Dear student, this reaction is also categorized in the reaction with metals. This reaction is the very famous reaction. The name of the scientist who gave this reaction is Woods. So the reaction name of this reaction is Woods reaction. But as of Grignard reagent, we not use magnesium. We use here an active metal like sodium. Always remember, in Grignard reagent we use active metal like magnesium, but in Woods reaction we use sodium as an active metal. Okay. Dear student, when alkyl halide react with the sodium metal, the halogen of alkyl halide combine with the sodium metals and produce 2NaX, and the alkyl of the alkyl halides connected to each others and form alkane. Dear student, always remember the reaction of metals, the reaction of alkyl halide with metals is the reaction of formation alkane. Okay. But one thing also remember, dear student, if you want formation of alkane as a product which contain same number of carbon as a reactant, then you used Grignard reagent reaction. Then you apply Grignard reagent reaction. But when you want to produce alkane which contain just double of carbon as a reactant. Then you apply Woods reaction, because in Woods reaction two alkyl groups are attached and the chain becomes larger than the chain of reactant. But in Grignard-Reisen reaction, the chain of alkane are similar to the number of carbon in chain of alkane is similar to the number of carbon in Grignard-Reisen. Okay. For example, here, if you take methyl bromide molecules, the molecule of methyl bromide react with sodium metals and forms an NaBr to a NaBr, and the CH3 and CH3 join each other. Dear student, you observe here in methyl bromide contain only one carbon, but the product contain two carbon. It means the product that is produced have the larger number of carbon as a reactant. But when you take CH3 MgBr and react with water, then compound produce CH3H plus MgOH Br. Dear student, you observe here the compound form have the single number of carbon which is equal to the same number carbon of Grignard-Reisen. Dear student, so we say that in Grignard-Reisen reaction, the compound form have the similar number of carbon as a reactant, but in Woods reaction, the compound form have the larger number of carbon as compared to reactant. Okay. Dear student, take a screenshot of the given content on the whiteboard, write down in your notebook and solve the question related to this topic. Dear student, in next lecture we will discuss chemical reaction of haloarenes, because this is the last lecture of chemical properties, chemical reaction of haloalkane. Okay, thank you very much.